Okay, in this video I'm going to continue with more examples of some counting problems. And in this first example, it simply asks what binomial coefficient tells the number of 7-element subsets a 15-element set has. Calculate this number. When we're counting subsets, we are not worried about the order, and therefore it is combinations rather than permutations. And the formula for combinations that we have, the number of k element combinations out of an n set is Cnk in general. This is also called the binomial coefficient. N factorial all over n minus k factorial and k factorial. Okay, so this is the general formula for Cnk, and we derive this starting with the Pnk formula, the number of permutations, and dividing by k factorial. So this is Pnk divided by k factorial, where Pnk is the number of k element lists that can be made out of an n set, out of an n element set. And then k factorial is the number of ways each of those k element lists could have been rearranged, and therefore that's the overcounting factor when we want to count just subsets rather than lists. In any case, the answer to this problem is C15,7. This is the binomial coefficient. It says to calculate the number, and I guess I forgot to do that. It's going to be 15 factorial over 15 minus 7 factorial, 7 factorial. And this is going to be 15 times 14 times 13 times 12. I'm going to run out of space here. I'm going to write it down here. 15 times 14 times 13 times 12 times 10 times 9 times 8 factorial. So I go from 15 on down to 9. And then I have 15 minus 7 factorial, which is that 8 factorial. And then I'm going to write the 7 factorial out. 6, 5, 4, 3, 2. And I don't have to say times 1. I'm going to go ahead and cancel the 8 factorials. I'm going to take a 15 and cancel it with a 5 and a 3. I'm going to take 12 and cancel it with a 6 and a 2. And I'm going to take a 7 and cancel it with the 14, leaving an extra 2 up in the numerator. And I can cancel the 4 and the 2, leaving an extra 2 in the denominator. So now I'm left with 13 times 10 times 9 all over 2. Boy, it really cancels out, doesn't it? So 9 times 5 times 13. And that one I can do fairly easy. Let me bring up my calculator. I forgot to calculate this one beforehand. Sorry about this on the video. 9 times 5 times 13 is equal to 585. Okay, so that's a great example of how you can simplify these things with lots of cancellations as you write out the factorials. And the first trick is to go ahead and write out the numerator all the way down and then use it to cancel one of the denominators. Okay, on to the next problem here. A club with 22 members wants to elect a president, vice president, secretary, and treasurer. How many ways are there to do this? Well, that's one of the mnemonics that we use. The P is for president, so to speak. And we are selecting a 4, 1, 2, 3, 4. We're selecting a 4-element list, that is an ordered 4 elements, out of 22. And so that is P 22, comma 4. Okay, and this is then 22 factorial all over 22 minus 4 factorial. This one doesn't have the extra k factorial in the denominator. And this comes out to 22 times 21 times 20 times 19 times 18 factorial. Here I'm doing the same trick I did before. Oops, I'm erasing half my words here. Same trick as I did before, where I figure out that the denominator is 18 factorial, and so I take the 22 factorial, go from 22 down to 18, and then from then on down, I let them cancel here. And then this becomes, well, you can just calculate this one. I did remember to do this one, and this is 158,004. 158,004 is the answer to number 8 on this one. These are very much like your homework problems. Okay, finally on this video, a club of 22 members wants to elect a president and vice president. And so that's a 2-element list and a 4-person planning committee. So here's a 2-element list and a 4-person committee subset. How many ways are there to do this? Show 2 solutions. And I forgot to write in here, and probably also in the homework, that the president, the people in the list can't be on the committee, basically. The president and the vice president are not on the committee. Okay? And it says 2 ways to do this. Okay, so it says how many ways are there to make the selection of the committee and the president and the vice president, and show 2 solutions. And what I'm going to do is I'm going to show you a solution where first we choose the president and vice president, and then we choose the 4-person committee out of the remaining club members. So here we choose the president and the vice president first. And the way we do that is we P is for president, so we're going to, out of 22 members, we're going to choose 2 of them to be the president and the vice president. Okay? So that's the number of ways of choosing the president and vice president. For every one of those ways, though, we can choose our 4-person committee this way. So I'm going to multiply these 2 numbers. This is the product principle. There's this many ways of doing the first step and this many ways of doing the second step. Now, because the president and the vice president are not on the committee, I've only got 20 members left to choose my committee from. So I'm going to choose from 24. Okay? And this comes out to be 22 factorial all over 20 factorial. And I'm writing 22 minus 2. I kind of did that in my head, and I got 20 factorial. Now with C24, I get 20 factorial in the numerator, and I get 16 factorial and 4 factorial in the denominator. After you do these for a while, you'll get to the point where you realize that the 2 in the denominator, when you do combinations, the 2 numbers in the denominator always add up to the 1 in the numerator. So n minus k and k add up to n. Okay, in any case, the 20 factorials cancel, and what we have here is 22 factorial over 4 factorial, 16 factorial. It's 22 times 21 times 20 times 19 times 18 times 17 times 16 factorial. Same trick as I've been using. 4 times 3 times 2 times 16 factorial. Maybe I'll hop back to blue here. Cancel the 16 factorials. 4 times 3 is 12. Let's see. Maybe I can cancel the 4 with the 20 and leave myself a 5 up here. Cancel the 3 times the 2 is a 6. It doesn't help a whole lot, does it? Yeah, the 18, and that'll leave a 3 up here. And if you multiply this all out, let's see, what do we get? All of the denominator is completely gone now, so I get 22 times 21 times 19 times 17 times 15. 3 times 5 is a 15. If you multiply this all out, you get 2,238,390 ways of choosing the president, vice president, and then 4 committee members from the others. And finally, I'm going to go ahead and choose the committee first. We sure hope that CTE stands for committee. We sure hope that we get the same answer, and let's do it. We're going to choose the committee first, so we're going to do the C first, and we're going to start with 22, and we're going to choose 4 out of that. And then we're going to choose our president and vice president out of the 18, which is 22 minus the 4 committee members. We're going to choose 2 out of the 18. And C22-4 is 22 factorial all over 18 factorial 4 factorial, and P18-2 is 18 factorial all over 16 factorial. And what am I going to get here? Let's cancel out our 18 factorials, and yes, we get 22 factorial all over 4 factorial, 16 factorial. Same thing that we had above. Okay, and so they're equal. So this is 2 different ways in which we can make those choices. No matter which order you do the choices, you get the same result. And I hope that helps.